Hi everybody, so this is the first video of our new unit Force and Motion, and this is lesson 1.2. This is going to be your notes video. So I wanted to first start off on the note sheet just to go over exactly what you guys have to do since it's kind of been a while since we've taken notes. So as you can see here, and this time in this unit I'm actually going to make, anytime you have to write something, it's going to be in red so that you know exactly where and when you need to write. So if you see an A, that means answer in your own words, and N is going to be notes from the video. Okay, so you can see there's a lot of A's in this lesson, and then down here there's going to be notes from the video. Okay, so starting off, lesson 1.2, describing changes in motion. And as you know, for the units in Amplify, there is a story that is being told throughout the unit. So this is going to be the video that's kind of gives you an intro to what the unit's going to be about.
All right, I've got systems up. Let's get eyes on the pod in the station.
Copy that.
Looking good. Registering expected speed. Target is ready to dock.
Anna, long time no see. So how's asteroid research going? What's the name of your project again?
Oh, the Asteroid Collection Mission? Call it the ACM for short.
Got any good samples yet?
Actually, I'm heading there right now because we have a pod ready to dock.
What did you get last time?
We got some dust and bits of ice.
Do you mind if I took a peek?
Actually, we don't have the samples here on Earth.
Really? Well, how do you study them?
Let me show you really quick. Our pod spacecraft is based at an unmanned space station, so it goes out to collect samples from the asteroid field. And then it flies back to dock and delivers them. Robotic tools in the space station allow us to analyze and photograph everything.
That is so cool. Oh, I'd love to hear more about that.
Well, the pod is docking right now. I'll let you know if we get any samples.
Good luck.
Want no coffee for us?
Very funny. Okay, this is Dr. Anna Gonzalez in Mission Control. Permission to start docking protocol.
Permission granted.
Okay, go for it, Greg.
Docking protocol activated.
Okay, 20 seconds. Nice and steady, just like last time, okay? Use the thrusters to reduce speed.
Copy that. Firing thrusters.
Okay, almost there.
No, what?
Okay, video's out. Somebody talk to me.
We've lost all communication with the pod.
Okay, try to reconnect.
Start up backup systems.
Backup system online. Still no contact.
Oh, we're back on.
Okay, what's the status?
Something's not right. It should have docked at the station by now.
Yeah, I can see it. It's going the wrong way. It's going away from the space station.
Something must have happened during those seconds when we lost contact.
Okay, Greg, I'm going to need you to run a full diagnostic on the space station and the pod. Everyone else, I need you to reconstruct what happened in those missing seconds. I'm talking to the director.
Okay, and so there's going to be two claims for this. What happened in those missing seconds. So claim 1 is that the thrusters cause the pod to move in the opposite direction, or claim 2, the thrusters slow the pod down, but it's not enough, so it collides with the space station. So take a minute and answer in your own words which of these claims makes the most sense to you. And here is just another way to look at it, so you can pause the video here and read these over, and you can take a look at these pictures to kind of help you move, decide which one you think is makes more sense. Okay, so now I am going to demo the launcher, and while I'm doing the demo, think of this guiding question: in what ways can the motion of an object change? So think about an object that's already moving can, and an object that's not already moving can. Okay, so just coming back to the notes here, we're going to go, I gave you an example of what I'm looking for here, and then I want you to fill in 4 more things to answer this question. And this video is going to show you guys exactly what you would be doing if you were in school, but I'll just show you in this video.
So to finish up that last.
Let me just skip ahead.
ahead and take a look at this video. Don't be afraid, and I'm going to remind you about this afterwards, don't be afraid to pause and watch the video multiple times so that you can try and get as many detailed observations that show all the different types of movement that you can see.
Okay, so just to go back, some of the things you might see here are this one, it's not moving, and then it starts moving. And this one, it's moving, 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 and then it moves faster. So those are just kind of examples of things you would write down in that chart. So you want to write down 4 more things. Okay, so the first example I gave you is an object that is already moving can slow down. You saw, right? It was the cap was moving and then it slowed down eventually. And maybe the second one, you would write an object that is already moving can start to move faster. And then watch the video if you need to a few more times and write down a few more. Now I want you to think about what are the 5 ways an object's motion can change. So use what you've learned in today's activity or watching today's video and think about this question. Put your ideas in a list and one response is already filled in for you. So 5 ways an object's motion can change. 1, it can start moving, right? It cannot be moving and then it starts moving. So think about 4 more, and next time I see you guys in class, we'll go over those 4. And then you're going to write down the definition of velocity at the end of your paper. So velocity is the speed in a particular direction. So this kind of gives you a little bit of an example of what I'm talking about there. And that is the end of today's lesson. So just like in the video said before, if you need to, you can rewind, pause the video anytime, watch parts over again. And that's the end of this video.